The only thing I really have to comment on today is I was able to follow Jeff's process of simulation 2 or let's get up to the beginning of here. Phase 2 simulation here, and download that and update. Well, let's see, share my get into Google for a second here. Share them. I don't know if you want my notes or not. I'll just share my notes here for a second and see if they're basically your notes, just formatted slightly different. Come here. Why are you sliding over there? Share button, share button, share. So I went through the process of building a clean laptop and doing a full desktop install, downloading Jeff's phase 2 and putting it into a separate directory, loading those dependencies, doing a cat can make on that, separate Catkin workspace, updating the bash file, updating the permissions on those files, adjusting the joystick to drive around. I just had to change those two axes. Then start Tab Planner and RViz and make a couple changes to RViz to show the robot model and the global planner and local planner, and drive around with, I think it was originally loaded with the SAMI parameters, and then open the robot URDF. And once I figured out that I needed all 3 of those, then switched to the Cub Cadet parameter along with the base machine and the SAMI sensors, and then had 4 windows and drove around. So it was awesome, and it all worked wonderfully well. So it was super cool. And now I'll go back to Slack and show so then when I first obviously load it without the sensors, you just get the base model with the bigger tires and the bigger wheelbase, And then when you load it with Sammy's sensors, obviously Jeff knows this, but then you get the sensor package. And now I understand that. So it's really well laid out and really well put together. So it's a wonderful piece of work that Jeff has put together.
So when you're showing those four windows where you're starting things up, were you trying to run the tab navigation planner and the joystick at the same time?
I don't remember if I mean, I'm trying to get back to that screen.
Technically, that's not supposed to work. It will work as long as the navigation isn't putting out move messages and your joystick isn't putting out move messages at the same time. That will work, because I don't have that command velocity mux stuff in there. So technically you run one or the other if you want to do that.
Are you seeing my screen right now?
No, I'm just seeing you.
Let's not be sharing here. No, I didn't press the share button. Yeah, so I don't remember exactly whether I had run this and that at the same time.
I see on those windows, you're not actually running those. You just have the command line up and they're not running. So I didn't know. I'm just saying, don't run them both at the same time, because you won't get the results you're expecting.
Yeah. So, yeah, so hats off, man. It was really, I mean, it's really a wonderful piece of work.
And I do want to restate, this is totally experimental and it's not meant to be a tutorial. So you're quite frankly, you're lucky you got it to work. So
now in the PyCar package, I mean, how much of that do you think is extra or required, to actually make it all work? Is it absolutely 100%, or do you think there's some extra stuff in there? Or did you ever spend much time looking at that whole PyCar?
there is some extra stuff, and I either just didn't bother to delete it, or because there's a directory called meshes, and it's got all kinds of meshes for wheels and various kinds of lidars and stuff, and I'm not using any of that stuff. But other than that, I don't know. I just took that package and started hacking and slashing on it, so I don't know what's changed and what's extra. I just made it. I just made it work for me, and then you requested it, so I put it out there, and I can't really tell you what else, how much of that is needed and how much is not.
Yeah, so for me, the next step was to think through what it would take to move it into the physical world, I guess. But it certainly was easy enough to get it to work in the simulated world. And then, I don't know, maybe play around with the URDF a little bit to, like, the chassis and make the model a little bit more, update the sensor package to be specific to mine and the positioning of the GPS and that kind of stuff.
So if you want to do that, instead of just hacking on what I got there, if you'd copy that URDF first and change it from whatever it says and make it say AL URDF, then you can hack and slash on it all you want, and then you won't lose the original one either.
Right.
So I was thinking one of the first things you might want to do is delete that second GPS antenna, since you only have one. And if you go look at that second GPS, there's a big block of code there, and it's got the first section that just makes it visible on the vehicle and places on the vehicle. And the second part that actually starts up the code to publish stuff, I've got that commented out. But you can just delete that entire block where it says, I think it says GPS 1, and it says like a tag that says GPS 1, and then at the very bottom it'll say /GPS 1. So everything in between there could be either comment it out completely or just delete it completely, since you don't need the extra antenna on there. And the other thing is, since I had two of them, I renamed my first GPS from GPS to GPS 0, and then the second one is GPS 1. So you could go change that. Anything that says GPS 0 in that first block, you could change back to GPS, and then it will publish as the topic will be GPS instead of GPS 0.
Right.
And you can also do this stuff by the remapping probably to get around that too. But just simply, I had two GPSs on there, so I named them something other than just GPS.
Cool. Yeah, but it was fantastic. I mean, to be able to drive it around. I mean, you made another post about changing the turning, one of the turning parameters. I've forgotten which one it was, but that was another tweak to make to it that I haven't done yet.
And I played with that. And if you just simply go in, fire up your a window that says echo Ackerman command, and then go to your, once you start this stuff up and it's running, you can fire up that dynamic reconfiguration. And I don't know how to get to it directly. I just type in RQT and it brings up this menu. And under there, one of the top tabs says something about configuration or something like that. And then you pull that down. Under that, it'll say Tab Planner. Then under that, you can bring up all the parameters. So in real time, you can change, like say minimum turning radius, and I can't think what the other values are you want to play with. But if you just change the minimum turning radius and then go to RViz and say drive over here and watch it, you can see what values it's putting out in the Ackerman command. So the field that says steer angle, as long as that never gets up to that that thing I posted, which I think was the max and min turning angle on the revolute joint of URDF. So you're telling the front end, you're limiting how sharp it can turn left and right. So that, just like on your real lawn tractor, if you get hard stops, you can't turn any further than that. So ideally you want to set the one in the simulator to match those. So you've got a left hard stop at so many degrees, then go into your URDF and that max and min limit there, set that so they match. But I just found that by driving it around, by turning the minimum angle and then giving it somewhere to go, you can watch to see how sharply it turns. And those are things that I changed in there, where you have to go change 2 or 3 extra files if you switch back and forth between vehicles. When I posted this whole thing, it was set up for your vehicle. It's just that thing I posted later saying you might want to hack your maximum turn angle in the URDF. That was something on top of everything else. So I don't think that's in the URDF code right now.
Cool. What's going on in your world?
Well, let's see, several things went on here. Last week I was talking about diagrams, and I didn't actually make up diagrams other than here's just kind of a hacked up diagram I did. And I was just simply saying, okay, if in the Gazebo world, I started to think what stuff talks to that. And the more I thought about it, then down here, you can actually break that up into multiple sections and say, well, the Gazebo itself, you feed in the world, and I wish I'd focus better. I can't even read that.
World one.
Anyway, let's see. Okay, got my screen back again. So anyway, it's got the Gazebo, and you feed in the world, and that's, I think URDF is what that is. And the URDF also goes into Robot State Publisher to put out your transforms and everything. And then over here, I've got that extra script that converts the pose from Gazebo into an odometry message. So that's a separate block over here. And then over here, you've got a separate block. And this is the one that's the Ackerman controller. So you put in from the bottom here, so I'll look at up here. So you put in the Ackerman command into that, and then it generates the values to talk to Gazebo to run your wheels. And so I was just thinking, going through the steps, do I need to break it down finer and finer to see this stuff? So there's just some scratch stuff that I was doing. And then I had another one here that was, what is that? This is just one that I did one time when I started thinking about this whole thing and how do you do this. So it's just kind of an overall block diagram of what's on the vehicle itself. So my low-level controller represents the microcontroller board that's on there. And then over on this side, where it's got the remote control receiver, it just receives the commands and talks back and forth over CAN bus. So that happens to be a communication interface. And then to talk to my computer up here, that's USB, so that's another communication interface. But all the things down here where I've got the pieces, here's the RC servo. So you just generate a PWM signal for that. So that's just a single control line, not a communication. Then I got my three encoders here, one on each back wheel and one on the, let's see. I don't know how these cameras focus. So anyway, later, if I do this, I can take a picture of my camera and post it that way, so it'll be readable. So anyway, it's got the 3 encoders, one on each back wheel and one on the motor itself. And each one of those has 2 wires that feed into the board to do quadrature decode. So again, those are signals, not communication lines. And then over here, I've got the motor driver, just like the ones your guys are using on your steering, but I'm using to drive my main motor in the back. So you got a direction bit and a PWM bit. So again, those are not communication, those are just control bits. And then down here, I got that PWM board that runs my flashing lights and everything, and that's just I2C. So it's really mixing 2 concepts on here. You got up at the top, you got the communication interfaces, and then down here you got control lines, but it just gives an overall indication of what's on the vehicle. So it seems like that'd be a reasonable thing. That'd be one of the steps when you're documenting your vehicle. And then the other thing is I was going back through, I went to the ROS Agriculture Index and I typed in diagram, and the first thing that popped up, Matt was showing a diagram he made of his stuff. And down at the bottom, so I'll say down. So down here at the bottom, he had a box that said hardware, and he had random things stuck in there like a Raspberry Pi and his IMU and motor controller and stuff like that. And then up here, he had a box that said, this is really weird since everything's backwards here. The middle box said something about drivers. So it's some kind of, like ROS nodes stuck into this box. And then up here, he had something else. I forgot what it was called. And it had other, the higher level stuff. So it's kind of a mix of nodes and physical pieces of hardware. And some of it was, showing communication between the nodes and the hardware down at the bottom. So it had lots of different things in there. He had lots of stuff on there if you look at it long enough. And if you watch his explanation on during that meeting, he tells you what's going on there. And that was and the other thing that came out of that was somebody said, what did you make that diagram with? And he says using draw.io. So there's a website called draw.io. If you go out there, it's a graphics editor that works like Visio. So you come over to the side, you grab a thing like, say, a rectangle, you drop it on the screen, you drop in something else on the screen, and you just grab it and drag an arrow from one box to the other box. So if you like the way Visio works, that works, and it's a free thing that's available out on the internet. And it gives you the option, do you want to save it to a Google Drive, or do you want to save it to various things on the internet, or you can actually save it on your computer. It's kind of kludgy doing that, but it does work. So you can say, once you get your diagram, you can say save it, and you say something about on this machine. And I think it creates, it just simply, I think, writes it to your download directory as whatever file you tell it. And then the second time you try to save it, it creates the same name, but you know how on Windows and Linux, if it's a duplicate file, it'll put a parentheses 1. So each time you save it, I think it keeps incrementing the number on that. So anyway, that's available. And if you're trying to do Visio type stuff, that works out. And then I was trying to think that if you're trying to do an actual, say, a wiring diagram, as opposed to, say, a schematic, you might have blocks on the page, and you might want to draw physical wires, say, from point A to point B. So like, say you got a battery, and on mine, I've got a battery with a fuse to the main switch. And then coming off the main switch, it goes to a fuse block. So you can draw individual lines in between that. So something like fritzing might be a good way to do that, where you put down the blocks to represent the battery and the switch and the fuse and all this, and then just draw physical wires, from the battery to the fuse, and from the fuse to the switch, and from the switch to the fuse block. And then the other concept you can do on that is if you pick a color code, and when I do stuff, I will usually use red as say a 5-volt line. And if you think about it in an IBM PC, you know, if you open up the desktop PCs, it's got the power supply in there. It's got a cable that plugs into the motherboard. Their standard is, I believe, 5 volts is red, 12 volts is yellow, and ground is black. And then they've got an orange line that's either the 5-volt standby or whatever they are. So anyway, there's a color code available there you can use. And now on a vehicle where you've got battery voltage as opposed to say 12 volts, because you can say 12 volts is regulated 12 volts, and then just call the battery voltage battery. And I would probably make that either blue or purple. And on one of my old robots, I think I used purple as the battery voltage. So anywhere on the vehicle where I had to use that, I use a purple wire so you could tell what that was. So if you go back to something like fritzing and then draw on these actual wires for a wiring diagram and use the color of whatever that is. So in this case, let's say my battery is going to be purple to draw those lines all the way up to the fuse block, and then from the fuse block out to whatever it's connected, those would all be purple wires. And then if I wanted to convert that into a regulated 12 volts, I could have a block that says DC to DC converter. So you put the purple line into it and coming out would be the yellow. Any wires coming out would be yellow because of the regulated 12 volts. And then I could have another block that's say a DC to DC converter that converts down to 5 volts. So I'd put a purple line into that and then have a red line coming out of that goes to whatever devices you have. Now, like in your case, you've got that USB, it's a powered USB hub, and you're putting battery voltage. I'm taking this from memory, but I think you're taking the battery voltage, putting it into that USB hub, and it regulates it down to 5 volts. So now all of your USB cables are putting out 5 volts on those.
Red.
And well, see, now here's another trick. See, at that point, a USB cable is not. Let me back up and say, so let's start at the battery. So you get the battery. I'm going to have a purple wire to the fuse. Well, coming off their side of the battery is ground. So I'm going to have a black wire coming off that going to I might have got this bus bar. It's about, I don't know, it's about 1/2 inch wide and about 3 inches long with a lot of holes in it. It's just a big solid piece of brass. So I'd have a wire that goes to that. So now on an actual wiring diagram, everything you hook up to is going to have a ground wire and it's going to have a power wire. So let's say, for instance, I'm just going to have a box called motor controller, for instance. And so there I'm going to run a purple wire from my fuse block to that box. And then I'm also going to have a black wire that goes from the bus bar, ground bus bar, out to that same block. So the advantage of that is that not only tells you that it is connected to battery, fused battery and ground, but you can know that it goes directly from that box directly to the bus bar. Because on the other hand, if you have like a schematic, on a schematic, you typically don't show the routing of the wires. You just say, well, these boxes, I got 3 boxes, they're all connected to ground, but you don't know if you have a single wire that goes from here out to the first box, and then daisy changes the next box, and daisy changes the next box, or does the top box go directly back down to the bus bar, and the middle one go back to the bus bar, and the bottom one go to the bus bar, that's the way I try to do mine. So I've got, say, my electronics box, I put in battery voltage, and I've got a ground wire, and the ground wire goes back to that bus bar to connect everything. So it's just the fact that an actual wiring diagram shows, like think of the lawn tractor wiring diagrams there that will show, here's something here, and then it's got wires, and they'll typically have 4 or 5 wires that go into just a they'll show a cable. So you have a cable harness, and then at the other end of the cable harness they separate out to go where they want to. So that's another thing you could do. You could do show a cable harness on a wiring diagram, or just draw individual wires. But that shows you, by looking at that diagram, it says from this box that there is going to be a wire, say a black wire, that goes right to my bus bar somewhere. So basically every box would have 2 wires for power. It would have like either battery voltage or 12 volts or 5 volts going to the box, and then it's going to have a ground wire that goes back to the ground bus bar. Now, when you get in your case, where you got the USB hub is actually doing communication and supplying power, well, now coming off there, you're going to have something that just says USB cable. You're not going to say, you could, it's implied the USB cable is supplying 5 volts because that's the way USB works. But I wouldn't make that cable red. I would just say it's a USB cable. And you can put a thing next to it saying, if you're trying to represent power, then right next to it, say 5 volts next to that. So that's some thoughts I had on that. It's the different types of diagrams you might want to make. So number one, you might want a wiring diagram. And I don't think I have any samples here that I'm scribbling up, but I know I just wrote that down somewhere. Anyway, I don't have anything handy, but that's the concept on for talking about power. And this also says we're gonna have a diagram with power, and you might want to have two. So you got one that's the overall block diagram, like well, more like this, but it would just be power, saying, well, the battery connects to those, and you don't have to mention the grounds or anything at all, just so you get an overall view of what. Here, let me fix my camera. There we go. So you see, you have like an overall block diagram saying, yeah, these things get power, and so you show your battery, and these just have lines going to all these different things, and then you can have an actual wiring diagram that shows the individual wires, and you can use color to represent what they are, and that all of that's separate from communication. So now you run into an issue where you're showing the communication, and oh, I know where that stuff is. It's on, well, I was doing it out on the draw IO thing. I was doing this, and it turns out, well, since the USB cable shares power and communication, now you can have a communication drawing. In your case, it's going to look about like your power drawing, because on the power drawing, you're showing the power going from a USB hub to each individual teensy. Now on your communication diagram, it's going to look almost the same, where you've got coming from the USB hub, you got a USB cable to the teensy, and now that's a communication interface. So that's kind of a shared thing right there. Now in my case, I don't have I don't have everything separated on USB. I do have several USB devices connected to it, but again, it depends on your implementation and what you want to have there. So I'm thinking you need something to show a diagram for power, maybe 2 levels of that, and then for the communication, you could have one called communication and have it all the USB cables, and then like on mine where I've got the the physical, again these physical devices on here, and they're connected here just by GPIO pins off my low-level controller. So that might be another way to do that. Now, technically, all this stuff here, except for the ROS computer, is all inside of one box. So I could have a diagram that says, once I get down to this level, here's a block diagram. This is a block diagram of what the low-level parts are doing, and then I could have an actual schematic for this box, because I have inside of my box, I put battery voltage into the box. I've got a 5-volt converter, so this converter puts out 5 volts through a diode to my microcontroller board. So if I plug a USB cable into the microcontroller board, on board it's got a diode that will allow power from USB to power up the board, or if I turn on my external one, I can supply power through a different diode into the board. So if either one of those 2 power supplies is turned on, the board will run. And if you're really critical about it, what you can do is put a voltmeter onto the pin going right into the microcontroller, and I can adjust that external 5-volt controller up and down. So on the other side, because the diode drops a certain amount of voltage, it's 0.3 volts to 1 volt, depending on what kind of diode you use, how much of a load there is. But by putting a meter right on the board and then adjusting the controller, I want that voltage to be slightly higher than the input from the USB. And that means it will draw power from my 5-volt controller instead of from the USB, because if it's from my USB, it's going to run my laptop battery down faster. And usually I don't care. Right now I just say turn it on, and it's one or the other is going to power up that board. But that's where it'd be appropriate to put a schematic and say, here's the way that power works on that board. And there's probably a few other things that most of my stuff is just simply connectors connected to the microcontroller board. So I don't have a lot of electronics in between. I guess.
So your laptop just runs off the laptop battery for however long it runs.
At this point, it does. I did buy a a DC to DC converter that converts. It's a boost converter, so I can put in battery voltage, and it'll put out my 19 volts that my laptop requires. And with some playing around, depending if you have a Dell laptop or an HP laptop. If you have a Dell laptop, the power adapter has an actual like an I2C ID chip inside of it, or it's like an EEPROM or something. So when you plug the cable in, the laptop goes out to the charger and says, tell me what this is. The charger says, oh, I'm a 65 watt Dell charger, and it gives some other stats on it. And then based on that, it decides how it should charge its battery. But it turns out the HP laptops, you just have to put a resistor from that center pin to the supply pin, and then it will charge. So it's not as sophisticated, which makes it much easier in my case if I want to do that. So the point is, I can emulate the external charger by just having a power supply that puts out my 19 or 19.1 volts and plug right into that cable. I just have to make sure I put a resistor across there so it knows that it should trust that or not. And the other thing was on this particular laptop that I'm using, I had never seen this before, but if you go into the BIOS, it's like on the desktop computers where you can go into the BIOS and say, when this thing powers up, what should I do? So if you say, you can set it to always remember the last state, or you can say always start with the power off, or always start with the power on, or you can just say, essentially you can say, if you say always on, and as soon as you plug the power cord into the wall, the thing will say, oh, I got power, and it'll go ahead and power up. Well, this is the first laptop I've seen that will allow you to do that. So I can set it to say, actually power up when external power is applied. So I can, if I'm real clever about this, I can have it where I say the low level controller can go out and say, turn on the converter. It supplies power to the laptop, and the laptop says, oh, I should power up now. And it'll go ahead and power up and do what it needs to. And when I'm all done, you execute the script in Linux that says, shut the laptop down. What is it? Sudo shut down now, or whatever that's called. And the laptop will actually shut down. And whether there's power applied or not, it'll shut down all the way, and then you can turn the converter off. So there's a lot of games I could play there to make that work. But yes, at this point,
in your background, go ahead. I'm sorry.
No, go ahead.
I was going to say, in your background image, you've got a picture of your robot. There's a plastic bin. Does your laptop sit in that plastic bin?
No, actually, in the real world, there's a second plastic bin on top of that. And then I put a bracket on top of that. So the laptop sits on top of that. So I got two plastic boxes, and the laptop sits on top of that. So
you just strap it down or something?
I should strap it down. And I went out and I bought some, went over to Walmart and bought some elastic. It's like 1 inch wide elastic that's, fairly thin stuff. And I think I could put that across the top to hold it down. Or like straps that come on laptop bags where it's got the nylon straps and those plastic clips to hook it together. I could do that, but at the moment it's not hooked down. I've just got some aluminum brackets to form a little like a cradle for it to go in. So I just lay the laptop in there, and as long as I'm not too violent, it can't slide off the side. But I really should have some kind of a strap. At one point I was also using a bungee strap, so I just clip it on the front of the front on the frame somewhere, and then run around the back and clip it on the frame, and that would go over the laptop and hold it down. So eventually, yes, I should do something to hold that down, because otherwise, if the laptop pops off there, it's going to break it, and I'll be screwed. So why do we go down this? I was talking about,
you were talking about diagrams, and I was just poking around how you were powering and
yeah, so I'm powering that low-level microcontroller either from the main battery through that converter, or directly from the USB over the laptop. And I was just saying that I can adjust that if I'm really, really anal about it. I can adjust that up and down. So if the battery one is on, that provides a higher voltage, and it'll run directly from that and not be drawing power from the laptop. Or say like if I had a Raspberry Pi instead of the laptop, it would be drawing power from the USB from the Raspberry Pi. So that's something else I could do. So I'm just saying that down at the low level, there needs to be a schematic of that board saying, here's the converter, here's a diode powering the thing, and then have a little box of the board that says this is the teensy, and then inside the teensy, it shows the USB coming in, and from there, there's a diode connected to the input pin. So I've got a diode external connected to it, and internal is connected to that. So whichever one has the higher voltage is the one it's going to draw the power from. And other than that, if I made a schematic of what's in that box, then otherwise I just got 4 or 5 connectors that are wired to the pins on the controller board. So again, it's just a level of like kind of a hierarchical view of what all these different parts are on the thing. So you end up with a bunch of different diagrams by the time you're done.
Yeah, I wasn't following any standards whatsoever, but this was my attempt at trying to document. I think it's still pretty accurate, except, yeah, it's still pretty accurate, but I need to like change it all now. But
and leave that up for a second. I'll point out that so back on the ROS agriculture, the second instance of searching for diagram, I think you presented this diagram and you explained some of the stuff you're doing there. And then the third instance of diagram was me talking about the same stuff I'm talking about now, saying, well, you need these different diagrams and you could do this and this and this. And in fact, there I started off and said, well, you could put up a diagram that's like a top view of your vehicle. So you show the wheels and a frame. And then on there, you draw little boxes saying, here's the left rear wheel sensor, here's the right rear wheel sensor, here's the motor sensor, here's the steering sensor, and so forth. You go and just put a number next to each one, and have a little thing that says, this is the left wheel, right wheel, the motor, the steering sensor, the RC servo, whatever they happen to be. And that way, that's another diagram that shows where they're located on the vehicle. So that was what I got on the ROS agriculture stuff by going back through the old videos on that. So I was just talking about separating out communication and power, and see on this is more of what I would call a high level block diagram. Can you show a battery with just a single line coming over to something called 12 volt? And I don't know if that is a bus bar or if it's a fuse block or whatever that is, which doesn't really matter what it is, but the point is you're not showing the ground returns. So this is not, an actual wiring diagram, what's hooked up. Parts of it are, say you got your steering motor, you do have a red and a black wire going over to the controller. And then between the teensy, you show 3 wires connected between there. But then like the power, just kind of overall thing, which there's no problem with that as long as it's understood. This is just a high level thing saying, here's the relationship between these things. And then also you've got you're showing from the USB hub down to your teensies there, those are USB cables, since I know what they are and you know what they are, we know those are USB cables, and those are doing 2 different things. It's supplying power to your teensies, and then it's also supplying the communication between basically your Raspberry Pi and each teensy. So it's just a matter of figuring out, if we can come up, just say, here's what I would suggest, and then people can do whatever they want, that type of thing.
yeah, your suggestions are great. I mean, because I was just trying to get something on paper, and I had no standards to follow, and so yeah, it would be nice to.
Yeah, as you pointed out on your video, you're saying, well, you saw what Matt had done, so this was your attempt to document your thing. And I wasn't completely happy with what Matt did because he had various concepts. I think he had power, and he had communications, and he had ROS nodes, and he had some of the ROS topics all on the same diagram. And that you need to separate that stuff out. In my humble opinion, I think you need to separate that stuff out so you've got the different concepts and say, this is back to the other point. If you have ROS nodes, is there anything else we need to look at on this diagram here other than?
No, I was just reminding you that I had spent time trying to put together.
I think this is the one that you presented on the video, so that if not, then you've got 2 different diagrams that you've created.
No,
so,
it's the same one.
Okay, so let's see, what was I saying? Oh, then the next thing is, so you get down to the point you want to show ROS nodes and you want to show topics, Well, you can fire up RQT graph and it puts out that diagram, shows the bubbles saying here's these different nodes, and it shows connections between them. Some of the connections say TF and some will be an actual topic. I can't figure out how to get that thing to show all of the topics. So for instance, if I fire up my simulator and it says here's a node called Ackerman controller, and then here's a node called Gazebo, and it draws a line from the Ackerman controller to Gazebo, and it puts a label on there that says topic, and it shows like left axle control or something. Well, there's actually 6 different topics coming across there, and I can't figure out any way to get it to turn on to show all of those. So on one hand, that's just kind of an overall view of how things are connected. And then if you make another diagram that actually shows, take those concepts and put your block saying, here's my Ackerman controller, and here's a block that is my Gazebo, and you can draw a line, actually there's a line between them, and put an arrow so you know what direction it's going, and then write on your diagram, list all the different topics under that. So that would be a better way, because as I say, the RQT graph doesn't seem to show all of the topics, and that would be handy at times to know that. And I did enough poking that it turns out if you use between ROS topic and ROS node, you can figure out, all the stuff. So if I say, you say ROS topic list, it tells you all the topics that are being published. And then if you say ROS topic echo, it tells you at this point in time, gives you an instantaneous view of what that topic is actually publishing. And I think, everybody is familiar with that. So if you say, echo Ackerman command, it gives you the block of stuff saying, here's all the values listed out that's on the Ackerman command. You can see them change in real time. Now, if you go to ROS node, you can say ROS node list, and it lists all the nodes that are currently running. And you say ROS node info and specify a node, say Ackerman command. Down below it says, this is publishing these 6 things that are like wheel control parameters or wheel control topics, and it's subscribing to Ackerman command. So that will give you the list of what's in there. So you could cut and paste the text out of there and put it onto your diagram. And I was thinking there's something else you can do with that ROS node that will give you more information also. But by using these different tools, you could, by hand, you can piece all this stuff together. So on your diagram, your hand-built diagram, you can say, here are my various nodes at least in this section. And then you'd say, here's the lines between them, and then cut and paste all the actual topics into there, so you can tell what's going back and forth there. Now, the other problem with the RQT graph, it's like, again, it's just an overall concept of how stuff's connected. So if you have multiple computers, say if you have a Raspberry Pi and a base station, and you pull up RQT graph, it shows you nodes, but it doesn't tell you what computer that node is running on. And again, I can't figure out any way to figure out how to find out from the system, where those nodes are located. So again, if you were to you're drawing your own diagram, you'd say, here's a box here that's stuff on, in your case, on your Raspberry Pi. Here's a box of stuff that's on your laptop base station. So inside of that box, then put the nodes there. And then you can show that they're, anything on this computer right here, you can show them talking to each other. And then to get to the other, say from the base station out to your Raspberry Pi, you'd have Wi-Fi. And then over here, you'd have, inside of here, you'd have all the stuff that's running on your vehicle. So that gives you one more indication of where stuff is located, because as far as I can tell, I can't figure out how to get ROS to tell you any of that stuff. You just, in that case, you just have to know. You go back to your launch file, and your launch file says, this is running on one computer, and the launch file on the other side says this is running on this computer. So that tells you where they're at. But it'd be nice to have that, directly in the diagram to show you what's there. So I was mentioning, so on the diagrams, I decided, yes, you need different types of diagrams, and we just talked about what those are and how to get information. I looked at the ROS agriculture videos, and the only thing I searched for was diagram, and that showed up those 3 instances that I talked about. It could be if I put in, type in documentation, there might be, a wealth of knowledge where people were talking about this stuff before. And then as far as the graphic editors, it seems like, originally I would always reach for Microsoft Paint, and that's just worthless to try to do anything, because you put down a box and it creates as a bitmap. So now you can't just move that box around. You have to put a thing around and drag it. And so that doesn't work. So I was happy to find that that draw.io website, because that will do like a Visio type thing. As long as you're doing the overall stuff that says, I got this box and a single line between those, that works out well, but you can't draw multiple lines with that because that's not the way the Visio type stuff works. And that's why if you go to something like, say, Fritzing, where you can put down multiple blocks and then draw, I assume you can draw as many wires between those as you want. And you can also color code the wires at that point. So that'd be another approach to that. And there's probably other graphic editors, maybe each one of these diagrams, you'd have to use a different kind of editor simply because of the type of information you're trying to produce or what you have access to. That's another big one. So if you're running Windows, you might have all the, I know you said you were using that whatever that presentation, that slideshow program was, like what you created your diagram with. And there's, just all kinds of different things. I think there was something called Microsoft Draw that was, several versions ago, they had that thing, and it was more like it was an object oriented type thing where you could put down a box and then you could grab the box and drag it around, as opposed to Paint that just simply draws on the screen and then you can't do anything with it. So, based on the tools that come with your computer, that might be another way to look at that. So it's just going to be kind of a journey. The other thing I thought of, I could just go to just go to like a text editor, or under Linux, you either get a thing that'll edit text, or you get something that's called the rich text format, which is equivalent to Microsoft Word. And then one of the text is like equivalent to Microsoft Notepad. So if you go to the rich text one, where you can put bold and different size fonts and whatever, you could create, just on one page, say, and I didn't print this out, but I did this somewhere. Actually, I've got a little note card, these little 3x5 note cards, like you put recipes on. I bought some of those at Walmart, and I took one of those cards. At the top, I wrote down, I think it said Gazebo, and then I put a line, and then under that, I put in the different things. Or no, the top said URDF, and then a line. So the URDF was the header. Then down below, I had lines. The first one said something frame/wheels. Then I had GPS, I had IMU. And so you do all that on a card. Now you can move those cards around and drop that onto a bigger piece of paper. And then, as you're diagramming the stuff, you put it down and then take a picture of it. So that'd be another way, a totally manual way to do all this stuff. So I can get nice looking text by just typing it in and printing it out on a laser printer, and then put that down, tape them down to a big piece of paper and draw lines between them. So that'd be another way to document the stuff. And
Fritzing, I've tried that once or twice, and it just seemed like the learning curve I didn't have the patience to fight through the learning curve on that. That's probably
I didn't actually try it, but I know, I see pictures of stuff people are doing, and everybody likes to put down a picture of an Arduino, a picture of a proto board. But I would probably just use it and say, here's a rectangle that represents my steering, like in your case, you've got your steering controller that's got the steering motor, the power driver, the 1 or 2 feedback, which at least one of yours goes all the way back to your Raspberry Pi, I think, over USB. But anyway, everything that's in there, I just have a box that says steering controller, or steering whatever, whatever you want to call that. And then in Fritzing, you can have the power wires. You have a battery wire, a ground wire coming into it, and then you have a USB cable that goes back to your Raspberry Pi. So that's the type of level I think I would use that for. It's just the fact that Fritzing lets you put in the multiple wire. I'm hoping that you can draw a wire, say draw a wire from here and come out and go like this, go like that. A simple way to do that, because the other programs I'm looking at, you can put down like that draw.io. If I say put a line, it pops a line on the screen, kind of an angle. Here's 2 endpoints, and you can drag the endpoints around to connect things. But if you want to put a bend in the wire, you have to create a second wire and put those together. I haven't figured out a way to join those together. So you still can't go back and easily edit that stuff. So it's just, again, it's just a matter of choosing a tool that seems like it will do the job and try it out. If it doesn't work, find something else, I guess, is the bottom line to that. So I spent all week thinking about this stuff and digging, and that's what I've come up with.
on your low level, so on your ROS computer on your robot is plugged in via USB to your low level controller. And then your remote control is plugged into that low level controller. Just wrapping my head around how you're doing that. And then you've got some code running on that low level controller that basically says, is ROS in control or is the radio control in control?
Yes, that's one of the things that it does. Basically, a low level controller does all the low level control. Well, I should say it does most of the low level control. Then there's other things plugged into the laptop itself. For instance, I got 2 GPS receivers directly on USB. I've got an IMU on USB, and I just stuck on a test thing on the front. I just taped a Arduino Nano on, and it takes the wire off my super servo just to read the position, and that has another USB connection back to the laptop. And I guess in addition, I've got my status strip on the back that's plugged in USB. So I do have a bunch of things that are on USB, but all the low level control of the robot itself is all going through that low level controller. It turns out I don't really have a whole lot on there. When I held up that diagram, I got the motor drive, I've got the PWM board for the flashing lights, I got my 3 encoders, and I got the super servo. Those are all, running off the low level controller board, which as I say, it's an Arduino like board. It's just a bigger, fancier version of that. So I just have like a command status type interface between the low level board and my ROS computer, which is equivalent to where you run ROS serial. It's the equivalent of doing that. So anyway, if I had diagrams of all this made up, then you can look and say, oh, that's how he's connecting that stuff together. And of course, once you get to that point, then it'd be nice to have a description saying what's actually happening, as opposed to the people that say, oh, well, C is self-documenting. So you'll find there you go to the code, there'll be no comments, there'll be no description, overall description of what's going on. But that's what it's evolved into, that people don't think you have to know how stuff works anymore. So the other things that happen, do you still have time to talk here?
Mm-hmm.
So the other thing that came up was on 2 weeks ago on Homebrew Robotics meeting, a guy from a university out in California was saying his students were asking, how do I simulate a radio direction finding beacon on Gazebo? And he was explaining that basically you can get a physical box you put on there, and its output is a direction to the transmitter and I think a signal strength to the transmitter. So basically it's a matter of, and this comes from the DARPA Subterranean Challenge, where apparently one of the things you can do is you could say, I want to drop a transmitter inside of a cave, and then the robot has to go find it or has to navigate using that or something. So apparently if you're going to run a physical robot, they will supply you with this receiver and a transmitter so you can experiment. So you can put that on a physical robot and it can drive around and do whatever you want with it. And then, so they were asking how could you put that into simulation? And I was saying, well, you just need to know where your robot is, know where the transmitter is, and you just need to figure out the angles and the distance between that. And I kept getting the pushback saying, oh, well, no. So how did they put that? Something about, no, we don't know where the transmitter is. Say, yeah, I know, but to simulate it, you have to know. It's think of your base station that you run on your robot. You've got a box out in the yard. You have to know where that is, and then you on the vehicle, you have to have something that communicates with that. So when you put that in Gazebo, you just drop in a GPS simulation block. And there you have to tell it, well, here's the origin in my yard where the point is, that's my 0, point. So basically, in order to simulate, you have to know where that transmitter is in order to get the code to work. And then it kept getting pulled off topic because people are saying, well, but okay, if you do that, then you have to be able to drive down the hallway and you have to avoid objects. And I kept saying, no, that's all ROS. You just need to simulate the sensor. And we kind of left it at that. And I said, okay, I'll think about that and get back to you next week. And I totally forgot about it until I tuned in this week, and that they were already talking about that. And I said, okay, no. And again, some people are trying to convince him, no, you have to worry about navigation and this stuff and this stuff. I said, no, you just need to know. You need to know where the robot is. You need to know where the simulated transmitter is, and just figure out the angle and distance to that. That's all you need to do. And I was pointing out, well, you could just type it in as a constant in your code. So you say, well, the transmitter, we're going to say it's at 12,5 or whatever, whatever numbers you want to put in there. And then you've got code that says, go into Gazebo and says, what's your current XY position? And to take the hard-coded XY position and just figure out the angle and the distance between those and publish that. And that, I kept getting the pushback, well, but we don't know where the transmitter is. Well, you have to know, because you have to have a reference somewhere. And I said, well, you could just drop an object into Gazebo. I said, create a cube, and you could name it transmitter, and just place that in the world somewhere. And that way in Gazebo, or when you're talking to Gazebo, you say, tell me the location of the vehicle, tell me the location of the transmitter, and again, do your values. And that gives you the advantage. You can come in Gazebo and grab the transmitter, drag it somewhere else and drop it again. And then it just automatically knows, it automatically updates everything. So I'm still getting a lot of confused looks on Zoom. And I said, well, I'll look at it some more. So after the meeting, I sat down, I wrote a program that does this. And I simply went out and I went into Gazebo and said, insert, I dropped a fire hydrant into the world. So now if you go into a Gazebo, do a ROS service and say, show me what's in the world. And it says, well, I see the base plane, I see an Ackerman vehicle, and I see a fire hydrant. So there's another call you can do that says, show me the information on the fire hydrant. It says, well, it's at this XYZ pitch roll, blah, blah, blah. It tells you where the fire hydrant is. And I can say, tell me where the robot is. So I say, tell me where Ackerman vehicle is. That gives me all the XY information on that. So that gave me the position of both of those when I asked for it. And then I just did the trig functions to figure out, what's the angle and distance from the robot, and published that. So I went through and got all that to work, and I sent him a script. It was just a Python script about 20, 30 lines long. I emailed that to him. Then later I thought, I wrote this under ROS1. It probably won't run under ROS2. So by that point it was like 4 a.m. So I wasn't gonna try. So the next day I fired up ROS2 and did that TurtleBot demo that you're supposed to run with this stuff, which does bring up an RViz screen and brings up a Gazebo world, and the thing runs. You can click on it and say navigate to this point, and that all stuff all works. And as soon as I tried doing some of the commands that I was doing in ROS1, they don't work anymore. And that so that means it would have to be rewritten to the point where you're gonna have to create a Python node that's ROS2 compatible. And to talk to Gazebo, apparently the commands, the services are now different to talk to that. And that took me down the path of trying to figure out how to get this information out, which tells me I have no idea how ROS2 works. So I'm back at that point where I don't know how the launch files work. I don't know how, as I say, talking to Gazebo, the services are working differently. And I haven't written my own node from scratch. So there's a mountain of work there to figure out how to get that to work. But it does give me a prime example of, I want to do this. I've got it working in ROS1. Now I'm trying to figure out how to get to work in ROS2. So that's kind of where I left on that. The fact I can just fire up their demo, which is very easy to fire up. It's just that I have no idea what's happening once it's running.
That's really cool. You should guys from the Jet Propulsion Laboratory and the company that does Husky, what is it, ClearPath Robotics?
Yes.
I think they won that competition 1 or 2 years ago. They've got a great video out on how they dropped transmitters along the way so they could have communications underground.
Yeah, I think that's different, because what this guy's talking about is something about somebody hides a transmitter or places a transmitter somewhere and you have to go find it, as opposed to, you know, if you're in like a mine where you've got all these different tunnels going different directions, that would be very valuable to say drive to an intersection, drop a transmitter, and then drive down to another intersection, drop another transmitter. And that way you've got a mesh connection between all that stuff. Because as people point out, the communications don't go through solid rock, at least very well. So yeah, you gotta do that kind of stuff. And the other advice everybody was giving this guy was, yeah, go watch who ran last time and see if they got descriptions of what they did, just to get you know, pointers on how to do all this stuff.
That's really cool that you tried to help them.
And he's in a position where he doesn't actually know, but his students said, how do I do this? So he's asking the people on Homebrew Robotics, you know, how to go about doing this. So we explain things to him, he's not real clear on what, you know, what we're telling him. And so I sent him this code that runs under ROS1, and well, I haven't heard back from him yet. So I don't know what they came up with.
Yeah, I'm getting pinged here. Unfortunately, I'm going to have to run.
Okay, I guess that's pretty much what I had to talk about this time. So
that's really great. Thanks again for sharing the simulation phase 2. I'll work on building a laptop and starting to work on my physical, re-implementing my stuff on my tractor, trying to move to the physical world.
yeah.
Good luck this weekend.